So guys, today we are going to discuss one of the important concept, and it is very, very crucial or very, very essential when you develop any real-time application, and that concept is HMAC authentication. So we will discuss what is HMAC authentication, why we need HMAC authentication, what problem exactly HMAC authentication is serving. Then we'll also discuss how exactly that HMAC authentication is going to be work. We'll also discuss, we have already discussed the basic authentication, we have already discussed the JWT authentication, then why we need HMAC authentication, and finally we are going to develop one complete real-time application, right, using HMAC authentication so that you will understand how you can implement HMAC authentication in your ASP.NET Core Web API project. So let us proceed and understand what exactly HMAC authentication. So guys, remember, so this HMAC authentication, basically you have to remember hash-based message authentication code. So basically this this is going to be combination of two things. One is a hash-based, another one is a message authentication code. So basically, what is hash-based? Now basically you have to use one hashing algorithm. So using the hashing algorithm, you are going to generate one authentication code, right, which is also called as a signature, right? So using the hashing algorithm, we need to generate one signature, and that signature is going to represent the current HTTP request information. And that signature we need to send in every and each request, right, coming, I mean, from the client to the server. So why we need to send, what is the important, how that signature is going to be generated, what are the different hashing algorithm you need to use, all these things we are going to discuss, right, in today's session. So first of all, we need to understand what is HMAC authentication. See, first of all, HMAC stands for Hash-Based Message Authentication Code. So basically, it is an authentication mechanism, or you can say it is a cryptographic request signing mechanism used to ensure two things. So basically, it is one type of cryptographic mechanism you can consider, which is going to generate a signing token, you can say, or you can say some signature, and that signature is going to ensure two things. What are the things? One is authenticity, and another one is integrity. So before understanding what do you mean by authenticity and integrity, first of all, you guys tell me, so in case of a JWT authentication, what exactly it is doing? In JWT authentication, it is validating whether the user is valid or not. Whether the user has permission, right? Permission to access the endpoint or not, right? So these two things, right? We are checking with what? We are checking with JWT. Am I right? Yes or no? So
Yes.
basically, you are generating one JWT token, access token, and that token you are sending in each and every request from the client to the server. Server is going to check whether that token is valid. If your token is valid, it is going to create the HTTP right claims principal object, and also it is going to set the list of roles. Then, based on the roles, right, it is also going to decide whether that particular user can access the endpoint or not. So basically, these two things are going to be done by right, is a WT token. So one is you can say authentication, and another you can say authorization. So these are the two things. It is right, validating, who validating these two things? JWT token. Now, now you guys tell me. So now I have two questions, right? I have some questions. So you guys answer me. So whether the request coming from a particular client, is that validation is going to be checked, right, by the JWT request, right? Authenticity. So what do you mean by authenticity? Authenticity means what? Now the does the request coming from the valid client? For example, let me give you the clarity. Suppose you are the valid client and I am a hacker. So you send the request to the server. That is fine. Right? As a client, you can make a request to the server. That is fine. But whatever request you are sending, for example, I capture that request completely, and once your request processed, I again send that same request to the client. Sorry, same request to the server. Does the server have the capacity to identify with only JWT based authentication from where this request is coming, whether it is coming from the valid client or it is sending by someone else. Is that going to be right by the server based on the JWT token? Yes or
No.
no?
No.
That means with only JWT token, authenticity is not there. The JWT token can only verify whether the token is valid, whether the user is valid, whether the user has access to the right to perform the action or not. But it doesn't identify whether the request is coming from a valid client or not. So that authenticity is not going to be provided by JWT token. The second problem, right, is that integrity. Integrity. Sir, what do you mean by integrity? Integrity means, guys, tell me, right? What is that spelling? Right? Guys, tell me, for example, I'm sending one request. You are sending one request. I capture your request and I modify the request body and I send that request to the server. Does the JWT authentication going to verify whether the request body is being tampered by someone else or not?
No.
For example, you send one request where you are sending some amount as 1000. And what I'm doing, I'm changing that amount to 1000 to one right million. In case of your two account number, I'm putting a different account number. That means there's no integrity check, right, with JWT based validation. Right? Clear or not? So
Yes,
this
sir.
authenticity, the request is coming from the exact client. The integrity, the request has not been tampered in the middle. That is going to be identified. That is going to be protected by HMAC in our application. So HMAC is going to ensure that request is coming from the valid client, the request is not being tampered in between, right? Once the request sent by the client, that is not going to be captured by someone else. For example, if you do some changes in between, then server is going to reject that request. If you once, once my request processed, again, if I'm sending the same request, right, as a curve, the server is going to reject that also. So that is the reason why we are going to make use of HMAC authentication. So authenticity, it will verify the sender and integrity. That data is not going to be tampered. So untampered data, it will ensure that the client request is valid, coming from the valid client, and at the same time, the data is not tampered in between once the request travel from the client to the server. Clear?
Yeah, in JWT we have a signing, right, to overcome this problem.
Sorry.
In JWT we have
Mhm.
signing concept, right? We are signing header and payload with whatever the
See, that is all. Suppose you send the complete request. I just capture that complete request as it is. If I send that request as it is again, then what will happen?
Will allow user.
Right? Are you getting my
I
point?
didn't I didn't understand what
So
you're saying.
you're saying like you'll be stealing that token, JWT token.
No, I'm not talking about the JWT token, right? That token is mandatory. But whatever the URL, whatever the header, whatever the request body, whatever the access token, if I capture everything and send again to the server, then what will happen?
Okay.
Is that going to be identified by handled by JWT?
No.
No,
What? Sorry, I didn't understand what you're saying.
I think for
In J
certain duration it will.
Right? So for example, you send one request order place event, you write order place the request you are having. So when I'm saying HTTP request means that HTTP request going to be composed of many things. So what are the things? You can have some headers, right?
Record.
You can have the payload. You can have right what I can say some method type like put whatever it may be. So these are the data what you are sending. You can send some headers. That header might be including right your authorization header, some custom header, whatever you are passing. Uh, and your payload means it is your request body. So if I got this request body and if I got your authorization header, and right, then can I send a request, right? Yeah, exactly same, right? I'm not going to change anything, right? Whatever the payload you are sending, if that payload is encrypted, whatever you are saying encrypted payload, that's fine. That signature is also encrypted, that is fine. So whatever the encrypted header or whatever the encrypted payload, if I got, and exactly the same request, whatever you are sending, right, from your application to the server, if I'm sending the same request, right, to the server, is the server going to detect that as a reply attack?
No, no, same you are sending, so no.
No. Second thing is that, right, let assume that whatever the encryption algorithm you are using, right, that is known to the, right, what I can say, client. So then what they can do, they can decrypt the request body. So once they decrypt the request body, if they do some changes within the request body, is that going to be handled by the AWT token that this request is being tampered?
But
Yes.
hacker will not identify, no, sir, if it is encrypted.
We check the
See,
bearer token, right?
see, whenever you are using JWT authentication, right, we have already implemented. Does the JWT authentication have any relation with the request payload?
No, it only check the bearer token in the header.
Exactly, it is only going to check whether the bearer token was present, whether that token is valid or whether that is right invalid or that invalid format, whether that is expired, right? Whether that again it can also validate whether the what are the claims associated and as for the claims, thus the user
Yeah,
can have access to the endpoint. But that
yeah,
JWT authentication, he can never identify whether the request is coming from a valid client, whether the request body is correct or not. So these things are never going to be handled by or checked by whom? It is never going to be checked by JWT authentication. Clear?
yeah. But we are checking in the client ID, client secret to check the client, right?
This is client-ID again. So what I'm saying, if I capture your complete request, then I'm going to send the request using the same client ID and send right. So you are not understanding. So when I'm saying I'm capturing your request means whatever the client ID right you are passing in the header, that also I got na.
Okay, so you are passing the same JWT token, only
Same
changing the
information I'm
field.
passing. Right? So,
Only,
right, if I'm passing a invalid client ID, then it might be going to reject that this client is not valid. But if
okay.
someone else sending a request on behalf of me using my client ID, then how my server is going to identify this?
Mm-hmm.
Right?
Okay, got it.
And again, if someone going to modify the request payload, then how the server is going to identify that the payload is being tampered?
Yeah, got it.
Right? So basically, whenever you are developing some kind of a banking application, financial application, healthcare, insurance, right? Some complex application where security is the major key factor, HMAC authentication is mandatory, right? So what problem exactly it is solving? Is that clear? How to solve this we will discuss. But what problem it is solving? Two things, right? One is it is going to identify the request is not being tampered. I mean, the request body is not being tampered. Also, it is going to identify that this is not a reply attack, right? Someone not capture your request and someone is not sending, right, your request on behalf of you, right? So basically, two things it is going to ensure. One is authenticity, another one is integrity. Authenticity means identify the request. See, authenticity doesn't mean that client is a valid client. Authenticity means the request is coming from the exact source. If someone else capture that request and send me, I can identify this is not the request is not coming from the client, it is coming from someone else. Integrity means it is going to ensure the data is not tampered,
Yeah.
right?
So verifying center is verifying the IP address, or what is that
No,
we are
no.
verifying?
I will explain how it is going to verify. That's what I'm
Okay.
going to discuss. I'm going to implement,
Okay, sir. Thank you.
right? See, so why we need HMAC authentication, please observe. Now, request or bearer token can be misused, right? They can be stolen and can be misused. Request tampering is also possible. Request tampering means anyone can modify your request payload, right? Reply attack, someone got your complete request, they can they can resend that request again, right? Not prove that the request was on-chain. So with the JWT token only, right? You cannot identify or you cannot ensure that the request is not being tampered. But with HMAC authentication, we achieve all these things. It will give you proof. It will ensure that request is not tampered. It is not a, right, what I can say, a reply attack, right? It is going to give you the best integrity and best authenticity for your application. So let us proceed and understand, right? Before understanding, right, how to implement, let us first understand how does the authentication work. So this is very interesting, and whatever I'm going to explain now, practically also I'm going to implement. See, so whenever I'm going to implement HMAC authentication, so you can see this diagram, I have split into two sections. One is client and another one is server. So as a client, what I'm going to do, as a server, what the responsibility of the server related to HMAC authentication, let us try to understand. So first of all, so HMAC authentication means, as I mentioned, right, it is going to generate one signature, one authentication code. For, for generating this authentication code, what I need a client secret. What I need a client secret. Again, right, what I can tell you is, now when the client registered with the system, when a client onboarding to the server, I mean, for example, I'm providing some services. For example, I'm having one payment gateway. So if any client, right, payment gateway means what? It can be consumed by many applications. So whenever a client wants to write in, you want to use my payment gateway API, they have to first register on my system, right? So once the client registered, the client will get two things. One is client ID, another one is client secret, right? So that secret, whatever the client is getting, that secret is going to be shared. Obviously, that secret is generated by the server. That means it is known to server, and the same secret is also known to the client. So client will get a client ID and a client secret. The client will store that client ID and the client secret securely. The server generates this client ID secret. That means the server also stored this information securely. So what you need to understand, guys, here, now when the request is transmitted, when the client sending the request to the server, at that time, client can only pass the public client ID. Client can never pass the secret. That secret is stored here separately. That secret is also stored here separately. So the first step, what you need to remember, now before any secure communication happen between the client and the server, they must share the shared secret key. One shared secret key that is going to be generated by the server, that is secretly going to be shared to the client. So once the client got the client ID and the client secret, then only they can communicate with each other, right? Only each other means they can generate the signature using the secret key. So how to generate the signature? Let us start. So first point is clear. So first of all, one secret key that is going to be generated by the server, that is going to be shared to the client. For each client, a different client ID and the client secret key is going to be generated. Is that clear? First point is clear. So first there should be, right, I mean, the shared secret key must be shared between both parties. Clear? Clear? I will practically show you how the client is going to be registered, how the client ID and secret is going to be stored, what we need to store in the database, what we need to return to the client, right? All these informations I'm going to show you. The first point is
Yeah,
clear. There must
we
be
did
a
the same.
shared secret key.
Yeah, we did the
Yes.
same for JWT, right?
Sorry.
We did
No.
the same thing for JWT also, right? We created
No.
secret
No.
key and secret
No,
ID.
no, no. So
ID.
in JWT, what is the use of right secret key? So am I sharing the secret, right? Whatever the secret I'm creating, that is only going to be used by the server. Did I share my secret key to the client? That secret key, what I'm generating, that is for generating the token. That secret key I'm not exposing to the client. So whatever the JWT application we develop, whatever the secret we use, that is for our internal purpose. That is only used for generating the token. Secret key we never share to the client. If you see whatever the application we developed with the JWT, we never share the secret key to the client. Clear?
Secret ID and secret key we are not sharing, only.
A client ID you can share, right, if any new client is registering. But the client secret we never shared in case of a JWT authentication. And guys, remember, whatever the secret, right, we are using for generating the token, and whatever the secret here for the client, both are not same. You have to remove. So okay, let me show you this one also. Whatever the JWT application we developed, where is that one? Auth server, right?
Sir, AES encryption, this one different.
Yeah, that is different. Everything is different. We are also going to discuss encryption in the next session,
Okay.
right? For example, if you look at this app.settings.json file, so here we are storing this secret key. This secret key is required by our server for generating the token. This sign-in key or secret key we never shared with the client. So for client, if you open our database, so what is that database? Authentication server DB. Okay, let me check the file. Auth server DB, right? So if you look at the database, so we are storing the client information, API, right? Client app is there. But in the client app, this is client ID, this is client secret hash. And this client secret hash is different, and this secret key is different. Getting my point? So this is the unique client identifier. And this is going to be a different key which we are using for generating the token. Clear?
Yeah, signing with the key. Yeah, this. But my point is, we are sharing this client ID, client secret to the client. That's what I'm asking. Are we sharing this client
JWT,
ID?
see, you just tell me in JWT authentication, whatever the client secret we are sharing, is that coming into the picture for by the client, right, while generating the token? So this client secret we are storing, why we are storing? Now in each and every request. So if you look at the client request, right, for example, this is authentication controller. So when the user registered, when the user trying to log in, so in the login request, you can see I'm taking that client ID and client secret. This client secret, what I'm taking from the client, that is not going to be this one. So this is the hash value, that
Yeah,
plain secret I'm taking from the client. And this client and client secret, what I'm taking, that is for client validation. Whether the request, whatever the client is trying to generate the token, so is that the client is a valid client in my system or not? So that
yeah,
validation purpose, I'm taking this one. Clear?
yeah.
And this client secret key, right, whatever the client secret, if you want, you can share with the client. That's fine. And this client secret, now the right, what I can say, client can use, right, for generating the what I can say token. I mean, the client can make use of this client secret for right generating the HMAC signature. But this client secret is only used for client validation. This client secret doesn't have any relation with the JWT token. Clear? Clear?
We. My point is, this is the two keys used to identify the client, which we are sharing to client. The same thing we are doing in HMAC. That's why. Maybe we'll see after you complete the session.
Yes, yes, yes. See, if see, for example, in this case, right, if you are not passing this client secret, if you want to only do the validation by right based on the client ID, that is absolutely fine. So it is only for the validation purpose. When I'm
Okay.
sending, but if you look at my resource server, so when the the client consuming the resource server, does the client specifying any client ID and client secret? Right? For example, I don't think you have attended that session. So because otherwise you should not ask this question. Right? For example, in authentic, okay, this is the application. This is my authentication server. So this is my resource server. So this resource
Yeah.
server having this controller. When the client consuming these services, does the client specify that a client ID and a client secret in each and every request?
No, in authorize attribute, we don't specify, if you are
Right?
asking that.
At this point of time, the client can only pass that right JWT token, right?
Yeah.
That's what I'm trying to make you. So, right, I'm not going to take that client secret in each and every request when the client is trying to consume any right resource server. But in case of HMAC authentication, when the client is trying to place one order, I need to verify right whether the request is coming from a valid client or not, whether that
Okay.
request is being tampered or not. So both are different. So you have to remember from the very beginning, HMAC authentication is different and JWT is different. JWT authentication main purpose is to identify whether the user is a valid user or not, whether the user has permission to access the right, what I can say, particular action method. So at the same time, client means right. Sometimes what happens now, not only we want to validate that user, but also we want to validate now from which client. See, whenever I'm saying client, don't confuse that user and client are different. It might be the same. For example, it might. So when I'm saying client, client means mobile application. Client means your desktop application. Client means your right Android application. Client means your web application. So where the user can consume your services. So whether that request, for example, if I'm sending one request, right, from mobile application, I have to identify whether that request is coming from that particular mobile or somewhere else. Whether that request is being tampered or not. So that's what we need to understand. Clear?
Sir,
Right? So,
we'll,
you have to
yeah, we'll see
remember.
after the session.
So, right, wait after the session, you have to remember user is valid or not, permission is access to endpoint or not. That is going to be done by the JWT authentication. Whether the request is being tampered by someone else, whether that is a reply attacks, I mean, someone captured the request and sending that request, that is going to be identified by HMAC authentication. That is very simple as it is from the beginning, right? From the very beginning, don't proceed with any kind of a confusion. There should not be any kind of a confusion at all. Why? I'm saying it again and again. Authentication and authorization is going to be handled by JWT token. Authentication and authorization. For example, if I'm using HMAC, I'm not going to check whether that user is valid or not. HMAC is not going to check whether the user trying to access the endpoint is a valid user or not. It is not going to check whether the user has permission to access the endpoint or not. That is not the responsibility of HMAC authentication. And at the same time, WT token is not going to check whether the request is being tampered by someone else or not, whether that is a reply attack or not. So JWT responsibility is different, HMAC responsibility is different, and in most of the secured application, right, nowadays, people are using the combination of both. So JWT along with HMAC authentication, that is a good, what I can say, combination. And along with the JWT and HMAC authentication, if possible, you can also encrypt the payload. That is also possible, right? JWT, HMAC, encryption. This combination of these three is the recommended approach in the right banking side. Particularly if you are taking the example of a financial application, these three things are mandatory. Clear?
Yes, sir.
Right. So now let us try to understand. So before implementing JWT authentication, the shared secret key must be shared, right, between client and server. Once the client got the shared secret key, then using that shared secret key, he can generate a signature, and that signature the client needs to send, right, in each and every request to the server. So let us proceed and understand how. See, first of all, once the client got the shared client ID and the client secret key, then it will start preparing the message. So message means what? Now for generating the HMAC signature, right? For generating that HMAC signature, what are the information I need? So I'm going to generate the signature. Signature means the client will generate the signature. So for generating that HMAC signature, what are the information as a client I need? So first of all, I need to identify whatever the endpoint I'm going to invoke, what type of endpoint is this? HTTP post, put, whatever it is. Then what is the API URL path? So what endpoint I'm trying to access, not the base URL. Guys, remember? So whenever I'm saying path, path means after the base URL, what is the endpoint? API slash order slash create, API slash order and order ID. So basically, what is the API path? And are you passing any query parameter? So that is also going to be right as part of your URL. So first of all, HTTP method. Second, what endpoint you are trying to access, that API path along with the parameter. If it is a put or a patch request, then you might be sending some data in the payload. What is that request body? This is not available in case of a get or delete. The shared secret key which you must get right internally, right, which you must get from the server. And the cryptographic hash function you have to use one. That hash function you can use SHA-256 or SHA right 512 right 32-bit. It will generate 64-bit. So right. So basically, what exactly this signature means? That signature is going to be a fixed length. So doesn't matter right how long that URL path query parameter, doesn't matter how big or how small the request body, even if the request body is empty, that is also fine. So this cryptographic hash function going to generate a fixed length string, a fixed length string. And if you are using 256, 32-bit, if you are using 512, 64-bit, right? That is going to be generated. Timestamp, now when this is generated, right? When you are generating the signature, what is the current date time? And again, this date time you have to provide in Unix format, right? Unix means what? This is also called as epoch time. So what is epoch time? I'm also going to explain right there. Then you are also need to provide a unique random value. So one GUID you can also pass now. So what is the use of this timestamp and nonce? That what also you are going to discuss, right? So basically, HTTP method, your URL path, your request body, if it has, what is the shared secret key which you must be got from the server, what algorithm you are using, and the current timestamp in Unix format. What is Unix for a Unix format or epoch time means what? Now from the 1971 till now, how many seconds are there? That the integral value we are going to pass. So based on that integral value, we can easily identify, we can easily calculate the time, right? Timestamp when this right HMAC signature is generated. Nonce means it is a unique value per request. So that is going to be generated by the client. So one unique value, the epoch time, along with all this data required, right, for generating the HMAC signature. Clear? Clear? What is the use of these two things? I will explain. Apart from this thing, all this thing is clear. What is HTTP method? What is URL path query parameter? What is the request body? What is shared secret key? What is ready cryptographic hash function? Is that clear?
Yes.
Clear or not?
Yes, sir.
Okay. Now, so once you have this information which is required for generating the HMAC signature, then the HMAC is going to be generated by the client. So once the message is prepared, the client generates the HMAC signature using the shared secret key and choose a hash function. This step, right, this generation step convert the request data into a fixed length cryptographic signature. So fixed length, 32-bit, I mean 32 character, 64 character. So that length, right, signature it is going to generate. So this signature uniquely represents the request, right? The client applies this HMAC algorithm. So HMAC algorithm, whatever you applied, right? Inputs include the message, timestamp, non-secret key we have already discussed, and the output is going to be a unique HMAC signature. Okay, and this signature, whatever I generated, right? If you do a small change, if you do a small change either in the URL path, either into the nouns, whether in the timestamp, whether in the request body, a single character if you change, then that HMAC signature is also going to be changed. Clear? A small change, even if you add a comma where anywhere, or if you remove a single character, if you just replace A with B, that complete HMAC signature is going to be changed. Clear? So whatever the data I provided, based on this data, it is going to generate a unique signature. If you later change something, then it will regenerate a new signature. The same signature, it will not generate. Clear? Clear, guys? So first step is prepare the data which is required by required for generating the HMAC signature. So once you have the data, then you have to generate the HMAC signature. How to generate that logic I'm going to show you right in the application. But once you generate the HMAC, right, then what you need to do, you need to send the actual request. So the way you are sending the request, you are setting the authentication header, some custom header, request body, whatever normal way you are sending the request, you have to send. But at the same time, right, normal HTTP request URL header body, if you want to include some client ID, right, all these things you can specify. But here, right, you need to send, right? For example, X HMAC, right? Any custom header if you want XMAC authorization, any header, right? Don't use authorization. If you have already used authorization, right? Then you have to provided a different header, right? Any custom header you can use because this is not going to do the authorization or authentication. Any custom header name you provided. And to this custom header, right? If you want, you can put this HMAC, that is fine. Then four things it is going to contain, right? What are the things? If you want, you can remove this also, right? What are the things this header is going to contain? Now, what is the client ID? That what you need to pass. Secondly, whatever the HMAC rate signature you generated. Thirdly, right, whatever for generating this HMAC signature, I'm providing two important information. What is the timestamp and nouns? This information I'm passing here, right? Client ID, HMAC signature, timestamp, and nouns. These four information I'm passing right into this header, custom header. So client ID, this is the generated signature. This is the timestamp that is going to be in Unix format and the nonce value. So now, why I'm passing this client ID? Why I'm passing this nonce? Why I'm passing this timestamp? Because at the server side, so whatever the signature I'm sending as a client, the server needs to verify this signature. Then how the server is going to verify? Now the server is going to reconstruct the signature. Then how the server is going to reconstruct the signature? Now based on the client ID, it will get the client secret, and you are providing this nonce and timestamp. So based on the right API path, he will get that API path and query parameter, and you are passing the request body. So all the information you will get, and then he will reconstruct the signature, and then he will verify with whatever the signature you provided and whatever the signature reconstructed by the client are same or not. If both are same, that is valid. Otherwise, it is going to throw some kind of a error. So once you send the HTTP request with the x-hmac authorization header, or any, so this is a custom header, you can give any name, then the server extract the requested data. So server receives the request, then server will extract the requested data from the right request data. Means it will identify what is the HTTP method, what is the URL path, what is the query parameter, what are the request bodies. So all this information he will get, right? Very easily he can identify what type of method is this get post put, what is the URL path, right? From the context object he can get. If you are passing any query parameter, that is also going to be get easily from the context object. If you are passing some data in the request body, that body also, right, from the API layer we can easily right extract. So once we extract the request data, then what I need to do, we got this HMAC signature, right? So from this HMAC signature, we need to extract the client ID, we need to extract the nonce, and we need to extract the timestamp. So once I got the client ID, then what I need to do? I need to check whether this client ID is a valid client. If it is a valid, what is the associated secret from the database? So we'll get the client secret. Then we'll got this nonce and timestamp. Then right, we need to apply the same hashing algorithm. Guys, remember what hashing algorithm we used here? That needs to be used by the client. So it is this hashing algorithm not going to be decided by the client. It is going to be decided by the server. So as a server, I will tell the client, hey, you want to consume my services? Okay. You have to generate the HMAC signature by following the standard HMAC rate SHA-256 algorithm or SHA-512 algorithm. And for generating the algorithm, this is the step, this is the process. What are the information you need to include for generating the algorithm? How you are going to send this information using what customer rate of the header? All these informations are going to be provided to the client by the server only through documentation. So you have to prepare one documentation. The documentation is going to contain all the information, how they can implement this SHA-256. I mean, see, all the APIs, all the programming language, they are having different right packages, right? Using those packages, they can generate this algorithm. But what is the flow? What is the standard? Standard means what are the data you need to put, how you are going to provide the data, what is the format of sending the authorization letter. This information you need to tell them, right? So that they can generate the same. right? So once the server extract the required data, and then what exactly it is going to do, it is going to again regenerate the HMAC. So using the same hashing algorithm, using the same set of data, it is going to same set of data means whatever the data it is receiving as part of the request, right? And it is going to regenerate the what I can say uh, signature. So once it regenerate the signature, then again here the twist will come into the picture. So what twist will come into the picture? For example, so if someone in the middle, they modify the URL, they modify the request body, then do you think that the hashing, the signature, what is going to be generated by the server, that is going to be same what I'm getting in the request? So if the hacker do some changes with the request, then when the server going to generate the same signature, right, going to generate the signature with the modified data, do you think that request is going to be a valid one? I mean that signature is going to be same, whatever the client is sending, or it is going to generate a different HMAC?
Different one.
Different.
Obviously, so what I'm saying, even if you do a small change, simply one character, if you put here and there, it will generate a completely new signature. That means if someone doing some changes right on in between, then does your server going to consider that as a valid right request? No. Why? Now because when it is going to generate the right, what I can say, signature, at that time he will identify, yes, the signature is different than what I'm getting from the request, so I cannot proceed further. I can write return to the client specifying that invalid signature, or this is a tampered request. Clear?
Yes, sir.
Right. Now you might have one question, sir. That is fine. But what about if the same request servers right the same request processed by the server first, the client send the request, as a middleman I capture the request and I have not done anything. Right, the same request is going to be processed by the server return. But once that first request is completed, the same right again as a hacker, what I'm doing, I'm sending the same request again to the server. Then how the server going to identify that it is a reply attack? Because at this point of time the data is not changed, right, everything is same. Then how the server will identify that it is a, right, what I can say, invalid request? Now for that purpose we are making use of two things. One is timestamp, another one is a nonce. So once the server receives a valid request, right, what exactly the server is going to do? It will store this nouns somewhere in the database. So it will store this nouns, and right, this nouns means it is a unique value for client, right? So this is a unique value per client. Now, when the user send the same request, when the user send the same request, then it is going to check whether this nouns value is already there in the database for this client. Same request is coming means what? That is going to be a
Tamper.
reply attack.
Correct.
Am I
So
wrong?
this nonce is unique for each request. That's what you're saying, right?
Correct.
Each,
Each record.
this is a unique for client.
No, client or each request.
See, see, client. So not so. For example, if two different client, if they want, they can pass the same nonce value. That's fine. Suppose
Okay.
I'm having three different client. So all right, these three different client can use the same nonce value and they can send a request to the server, right?
Okay.
Because
But
right, for example, if you are a independent client, I'm an independent client, and in your database, right, you want to send a unique value, right? How you are generating that unique value, it is up to you only. So whenever I receive the request, I need to identify that is unique to you only. I'm not going to check whether that is unique to other client or not. For example,
yeah,
if you are using,
yeah, I understand. So assume that there is one web client based SPA based web client. We are having one nonce that is unique identifier. So for all requests, he will send the same ID or he will generate the new one. That's what I'm asking.
See what I'm saying. So what I'm saying, unique per client means unique per. So if you are getting confused, unique per client request. Clear? So whenever the client sending a request for that particular client, this value needs to be unique. So
Okay, then how it
if one client sending 5 requests, then 5 different nonce value needs to be sent. So
that's
what
what
I'm
I'm
saying,
asking.
unique per client request. But the same nonce value can be used by a different client, but only one
Yeah.
time.
So it is client generating, right? So the attacker also generate and add instead of the same one, right?
If the attacker generate a new nonce value, then whatever the signature going to be generated by your server, that signature is going to be same or a different signature. If the attacker change this nonce value,
Different.
then so
It will
now
it will be
that condition we have already discussed. The attacker can never do any changes in the request. If it is doing
okay.
some changes either in the timestamp, either in the nonce, either in the request URL, request body, anywhere, it is going immediately. It is going to tell this is a invalid request. But now
Okay.
let assume the attacker doesn't change anything, and he immediately, right, once the request is being processed. So what he is doing now, he is sending this right again, right, sending the same request again to the server. Now,
Okay.
the server is going to check whether this nonce is already used by this particular client. If it is already used, then what it will do? Now, it will consider this as a blind attack. But at the same time, right, as you can see, my application can have 1,100 clients, and each client they are sending 1,000 requests per minute. Then I cannot store this nonce in my database for a longer period of time. Are you getting my
Yeah.
point? If I'm
Yes.
storing this nonce value for a longer period of time, then the database size is going to be very huge. So what I need to do is that this nonce value, whatever it is unique per client, but it's having a time period. So TTL, we need to specify time to live, right? So the TTL you just said that the 5 minutes. So 5 minutes, right? So you said it as a 5 minutes. So what exactly it means? It means if the same client, if I'm getting this nonce value within 5 minutes, then only it will consider this is a invalid request. After 5 minutes, this is going to be deleted from the client. Getting? So within 5 minutes, so if I'm getting the same request within 5 minutes, then it will tell, right, what it will do. It will tell that this is going to be invalid reply attack. Within 5 minutes means it is going to be a reply attack. Clear?
Yeah, means
Because
it will be same request, means same HTTP method they will use.
see, everything is going to be same. So same
Okay.
request. Let assume I'm sending the same request. So already that request is being served by the database. I mean by the server. That means this nonce value is already there in the database. So if the
Yeah.
hacker, right, this is already there in the database, right? Now, if the hacker within 5 minutes, let assume within 5 minutes, right, once the request is being initiated, after that, within 5 minutes, the hacker sending the same request again to the server. The server is going to check whether this nonce for this particular client is available in the database. Yes, it is available. Then it will consider that this is a reply attack. So why at this particular point of time, nonce is available in the database. So let us assume nonce available in the database, nonce in DB. So it will consider this is a reply attack. So now what will happen? Now after 5 minutes, so after 5 minutes, this particular nonce, whatever I am saying, it is deleted from the database. So what I'm saying, nonce deleted from DB. Clear? So because I cannot store this nonce value for a right, very long duration because that will cause application performance degradation, right? So after 5 minutes, this right, whatever old nonce values, they should be deleted from the database.
So how are we
Clear?
storing like separate table to maintain the nonce with the client ID? How are we maintaining that?
I'm going to implement, right, what is the structure,
Okay.
what is the signature. Practical, I'm going to show you. First of all, let us understand theoretically, right?
Yeah,
So
fine.
that value is going to be delayed. So I have to create one job scheduler, right? Or you can say you can create some kind of background task. right? So that background task is going to be run in every 5 minutes. It is going to check how many nonce are there, which is older than the right time period, right? I mean current time plus right less than the current time plus 5. So accordingly, it is going to delete those nonce from the database. So that's fine. So after 5 minutes, this is deleted. Now the hacker sending the same request after 5 minutes. Then what will happen? Now, after 5 minutes, what will happen? So, after 5 minutes, so is this data is going to be available? I mean, this nonce is available in the database? No, the data is not available. Then it will not identify that right after 5 minutes, it will not identify that this is a reply attack. Are you getting my point?
Correct.
Server will not identify after 5 minutes that it is a reply attack. Why? Because that nonce is deleted from the database. And that is the reason why we are using this timestamp. So basically, what exactly this timestamp is going to tell? Now, this timestamp is going to, what exactly this timestamp going to contain? It is going to contain when the signature is generated, right? When the signature is generated, that value it is storing inside the timestamp in unique format. Clear? Yes or no?
Yeah. Yes.
Right? So from this
Yes.
signature,
Yes.
what I can get, right? From this signature, I can get the date and the time. I can get the date time. So what I need to define? I need to define a time window. So let's assume 5 minutes. Okay, so I have to define one time window. Let's assume 5 minutes. So what exactly it means? Now, if this timestamp value plus 5 minutes, right, is greater than the current time. Right? If it is greater than current time, then what I need to do? Invalid request. Right? See. So basically, what exactly it means? It means if the hacker does some changes within the data, immediately my application will consider this is a invalid request because signature is mismatched. Within 5 minutes, for example, request is processed by my application and the hacker sending the same data again, same request again. So within 5 minutes, this nonce is going to tell that this is a reply attack because this is available in the database. Then after 5 minutes, then this timestamp is going to tell, right? My server is going to tell, I cannot process this request anymore. Why? Because the timestamp what generated and the current time is greater than the time window what I provided for handling the request. So in this way, HMAC is going to ensure that the request is not tampered, request is not right, that request is not a reply attack also. Clear?
Sir, how will generate the nonce based on the client device?
So nonce it's a GUID.
Okay.
So what I'm saying, nonce means it is a client value, unique value. So for example, as I am a client, I'm consuming some services. I have to provide a unique value for each request. Right? For example, if you remember, have you ever integrated any payment gateway? So when I'm initiating the
Okay.
payment gateway, right, I have to provide one unique transaction number that is going to be unique in my system. Server that PG will return one transaction reference number. But when I'm sending a new request, I need to provide a unique number or not,
Yes.
unique transaction ID. So how you are
Correct.
generating the unique transaction ID? So it is up to you. If you want, you can go with 1, 2, 3, 4 like this. If you want to go with the GUID, that is also fine. So basically, you have to generate a unique value. How you are generating it is up to you only.
Okay.
Clear?
Same we can send, we will get something based upon the payment gateway. So, for example, in our scenario, we will send the same one. We will get duplicate request from the payment gateway.
Okay.
Sir,
Right.
here you are seeing the timestamp. We are checking if it is more than 5 minutes, you are invalidating the request. That's what you are saying, right?
Okay. So what is our window, right? So within, right, once the client generate the signature, that signature validity is 5 minutes. After 5 minutes, my server is not going to process that request.
Okay.
Clear? And before 5 minutes, this nonce is there in the database. If it is a reply attack, he will identify that it is a reply attack. So in this way, it will
That's
ensure
okay.
both authenticity and the integrity. The data is, if any small changes in the request date, it will not handle. If it is a reply attack also, either within 5 minutes or after 5 minutes, also my server is going to reject that request. Clear? Clear or not?
Yes, sir.
Yes, clear.
Now, anyone having any question? So this is all about theoretically. Now it's time to implement this practically. Anyone having any question?
So, like for each request, it will generate a unique nonce value, right?
For each request per client. So you have to misunderstand. For example, in my database, right? For example, I'm creating one database for rate as a client. I'm having one database for a unique nonce value. That ID column value is one, rate integer type. Then how it is going to generate the rate unique value? So like this, 1, 2, 3, like this.
Yes.
Another client is there, so their database is also right storing that id is integer, so that database is also generating 1, 2, 3, 4. That means this is going to be unique for request for client. So the
Okay. Like suppose the same client is sending another request within that 5 minutes, another same request. So it will generate a new nonce value, right?
so what you are understand, I'm not getting. So why right who is generating this nonce value? First of all, tell me.
Server.
Sorry? So that what you understood, right? After right 1 hour, you are saying that nonce is going to be generated by the server.
No, client will send.
Definitely. So who is it?
Who
Server
is
is
the
only going to
requester?
validate the data. Server
Mm-hmm.
responsibility is to validate the request. Who will prepare this data? Who will send this signature? Only the client only. So what I'm discussing here, right? What I discussed. So message is going to be prepared by the client. Client is going to contain all these things. Prepare the HMAC signature. Then the client is going to send this HMAC signature in the header. The client ID signature, nonce and timestamp. This nonce and timestamp is going to be generated by the client only. Server is going to check whether that value is a valid value or not. Server is going to, whatever the value I'm getting for that particular client, I can store that in the database to ensure that the same request is not coming within 5 minutes or within 10 minutes. Generating is different, storing is different. That nonce value is going to be generated by the client. That timestamp is going to be generated by the client. That nonce value, whatever I got from the client, I'm going to store in my database. Clear? So it's
Okay.
possible that one client can send this value one, another client can send this value one also as nonce. So, right, if two clients are there, so for them, right, so you understood what do you mean by composite primary key?
Yes.
Yes.
Yeah, including of like multiple columns.
Composite primary key means a multiple column uniqueness. So here, this is going to be unique for client. So whatever the nonce value, whatever the client ID, that needs to be unique. The same nonce value can be used by a different client, but the same nonce value cannot be come from the same client within 5 minutes. If it is coming, it will consider that is invalid. Clear?
Like if it is a valid client also sending that same request also, it will consider it as a reply attack, right?
Yes. Within 5 minutes, you cannot send the same nonce value. Whether the request is coming from the valid client or someone else, it will consider invalid. Clear? Because that is what we are saying now. We are saying to the client, hey, Mr. Client, please send a unique nonce value per request. How you can send the same nonce value right multiple times? This is not acceptable. You have to send unique, right? Yes, we are removing this data from our database. They can reuse some old value, right? But after 5 minutes or whatever the time period we provided. Clear? But generally, it is always going to be unique, right? The client is never going to send the same nonce value 2 times. Clear? But if they are sending, that's fine. But after 5 minutes.
Okay.
Yeah. So now let us proceed and see how we can implement this in our project. So basically what I'm going to do, I'm going to create two applications. One is for the client application, another one is going to be the server application. So server responsibility is to validate HMAC. Client responsibility is to generate the HMAC and send that HMAC in each and every request. So what I'm going to do, I'm going to create two applications. Let's start with the HMAC server app. So open Visual Studio. So go to a different directory. So click next button, click create button. So once the project is created, next we need to install right EF core related packages for SQL Server. So let me proceed and install these packages. This is the package for the right database provider. This is the package for the migration. So these three packages I have installed. Now what I need to do, I need to store client information as well as a nonce, right? The client nonce in the database. So first of all, what I need to do, I need to create a entities folder where I'm going to create two entities. That means what? My database is going to store two tables, right? One table for storing the client information, another table for storing the client nonces, right? Nonce values. So let me first of all already create this class file API clients. So whatever client information you want to store, that what you need to store. So here you can see client ID, client name. So this is a right unique client ID. This is client name. Whatever the name you want to give, you can give. Whether this client is active, that client secret. And again, guys, remember this secret is going to be different. So whatever the secret we will share, right, to the client, that encrypted value we are going to store here. Guys, remember here we are not going to store the hash value. Hash is different, encryption is different, and here we are going to store the encrypted value. Why? Now, for example, if I generate one client key, right? For example, one client key I generate something like this. Some right, let assume something like this. At the rate of 1, 2, 3, 4. So this is my client key, and this client key I will share right to the what I can say server. But in my database, I cannot store this client key in plain format. So what I need to do, I need to encrypt this client key. And once I encrypt this client key, whatever the encrypted value I got, right, something like this. So this value I'm going to store in the database.
In JW2, we did hashing, right?
Right? So why
In
you are
JW,
comparing this JW2 with this API, right? This what I
no,
can say.
that's
What
fine.
I'm saying, whatever the secret key we are storing, right? That is fine. So if you are storing that hashing, that is fine. But here,
Mm.
what I'm going to do is, so see in JWT, so whatever the secret key we used, that is only for the client validation. But
Okay.
is that secret key being used in JWT authentication? Are you getting my point? So whatever the secret key we store in the client table, what is the use of that secret key? That secret key only going to check whether this client ID and the secret key is valid or not. That's it.
Yeah.
But that doesn't use, right? Whenever I'm consuming any resource server, is that secret key coming into the picture? When I'm
No.
generating the token, right? Is that secret key coming into the picture? No. So in that case, if you are storing that in right hash format, that is fine, right? Also, you can store in encrypted format. It is up to you only,
Okay.
right? So this is going to be my secret key. And again, when the secret key is created, when this is right, the secret key is going to be expired, and what algorithm you are going to use for generating the HMAC signature, right? I mean, for the validation purpose, the same algorithm we need to use. We are going to use HMAC, right? 256 or 256. So this is going to my API client. Then for right each client, there can be a list of or you can say associated nonce values. So for that purpose, I'm going to create another table, and that table is going to be this one. Right, so you can say ID, API client ID, API client. So for which client this nonce is associated, that value we are going to store inside this table, and the timestamp UTC and when it is going to expire. So this is the nonce value, and when this nonce value is going to be expired. So for example, when I'm storing this one, for the next 5 minutes, it is going to valid. So whatever the current date time plus 5 minutes, that is going to be the expire time. So that's what I'm going to store inside this table. So right, whatever the nonce, and this nonce is related to which API client, that information I'm going to store here. Clear? Clear?
Yes.
Right. So now what I need to do, I need to create another folder where right, I'm going to create my DB set properties. So data folder I have created, and within this data folder, I'm going to create one class file that is of DB context. Any name you can give as per your requirement. But what is important, this class must be inherited from the DB context class. So let me go ahead, and here you can see I have registered my DB set property for API client, property for API client none. So this is going to be right, one table will be created with this name, another table will be created with this name. And again, here you can see I'm providing some Fluent configuration for API client. What is that Fluent configuration? Now, in this case, this client ID must be unique. So that's what I have provided here. Client ID is going to be unique. That a client ID maximum length is 100 character. It is a required field, right? Here you can see uh, that max length and required we have already provided here. So if you want, you can go with this validation. Otherwise, you can comment here. Why? Because already we have provided this max length and required using data annotations, right? So client name, again, it is required and max length. Suppose I don't want to provide here. So then in that case, what I can do, I can make the same thing, right, using my Fluent rate configuration. And secret key, this is going to be also a required value. Secret key, this is also a required value. So we have already applied that required data annotation attribute. So if you want the right, you can do it. If you are applying both, then Fluent API will take the priority. That is also possible. So now this is my client nonce value. So you can see this is my table. So in this table, I want to create a composite index, right? You can see that application ID nonce value, that is going to be unique. Clear? So in this table, whatever the app client ID and whatever the nonce I'm going to store, that combination needs to be unique. That duplicate is not allowed. Clear? Clear or not? So
Yes.
same nonce value you can have with a multiple client, but for the same client, you cannot have, right, the same nonce value multiple times. You can use with different client, but not with the same client. That configurations we have provided here. Now again, right, I'm going to create a security folder. Inside this folder, I'm going to create some security related class file and helper methods. So let me create this one. So first of all, I'm going to create one options class, HmacOptions. So basically, I'm going to make use of right options pattern for our application. So I'm going to provide some HMAC related settings in the app settings.json file, and from that setting, I want to read the values to this right strongly typed .NET object class. So what are the values I'm going to provide? Enable. So do you want to enable? So this property is going to store a Boolean value, which is going to tell whether HMAC is going to be enabled or disabled. If true, HMAC is enabled. If false, HMAC is going to be disabled. Header name. So when the client is going to send the HMAC, then in which header the client is going to send the right HMAC signature, and accordingly my server is going to use the same header name to retrieve the HMAC values, right? So once the request comes, then from which request header I need to get the HMAC details. So that header name is going to be this one. Again, you can configure this into the right uh, app settings.json file. Allowed clock skew means what? It means the maximum allowed time difference between a client and a server to reply attack. So basically, within 5 minutes time period, right? Within 5 minutes, if the request is coming, right? I mean, So when the request is being generated and when it is going to be processed by the server, maximum 5 minutes different is going to be there. After 5 minutes, server is not going to entertainment, right, that request anymore. So that the second condition what we discussed here, right? Where we discussed that one. Right, so this condition what we discussed, that what I'm provided here, that maximum 5 minutes difference between client and the server. After 5 minutes, server will consider this is a invalid request. So nonce-TTL means what? Now whatever the nonce value I'm going to store in the database, that value is going to be valid for the 10 minutes. So within 10 minutes, if the same client sending the same nonce value, then it will consider this as a invalid request. Maximum body to sometimes what happens now, right? We know that maximum 2 MB data is sufficient, right? Sometimes what happens, now denial of service attack. Denial of service attack means what? Now intentionally the hacker, right? They wants to what exactly? Uh, they wants to increase your CPU processing time. So basically, what they are going to do, they are going to send some dummy request with a huge request body, some dummy request with a huge request body, and again, right, in decrypting that request body, generating that hash going to take some time. So basically, we know that my application can send a maximum of a 2 MB, right, a maximum body size. 2 MB is more than sufficient. That validation I'm giving here. Even this is optional. If you want to ignore this one, and if you want to, right, don't provide any kind of a restriction related to the, right, the request body length, you can completely ignore this one. That is absolutely fine. So skip path means what? Now where exactly you want to skip that HMAC validation. So you enable HMAC, but some of the endpoint, for example, Swagger endpoint, for example, that client registration endpoint, right? Some other endpoint where you want to enable HMAC validation. So that path details you need to provide inside this array. This come. So basically, these properties, whatever we defined here, all these properties are going to be created inside offsetting.json file, where you can specify what is the actual value. If you provide it, that's fine. If you don't provide it, this default value will come into the picture. And using option button, we can create an instance of this class within the program.cs class file. Clear? Clear, guys? Is that clear? Anyone is here?
Yeah,
Yes,
clear.
Yes.
Because right, you guys are being silent, so I thought you guys are slept. So otherwise, I have to go and I have to sleep. Okay. So this is going to my HMAC pass header. So basically, you can see when the request is coming, that a header is going to contain some data. So what data? Client ID, signature. It is going to contain that nonce timestamp, right? So that header information I'm going to store right within this one. So what is the client ID? What is the HMAC signature? That nonce value and timestamp. So this four information, what I'm getting right in which header, what I'm getting inside this HMAC authorization header. So that header value I'm going to split and I'm going to store inside this class. Client ID, client signature, that nonce value and the timestamp. So that is the
The
reason
max
why I have.
body you have, right? Max body in the hash op MAC option. What is
Sorry?
that? In the HMAC option, you have the the max body bytes to hash. So that
Just ignore this, right? I have already told that this is optional. Means what? Now, sometimes, do you know what is the meaning of a DOS attack?
like using bot sending the request to download the server.
Exactly. So basically, what it means that they want to uh, they want to send some request so that it can increase your CPU processing power, so that the performance is going to be degraded. So basically, what exactly some hacker they are doing now, they are sending a huge request body in the right request, and when you are generating the hash value of a right huge request body, it is going to take more time. So basically,
Okay.
with this one, right, what we need to do, we need to provide a restriction on the body. So basically, right, I know that maximum 1 MB data is going to be there in the request body. So I said a maximum body size is going to be 2 MB. So after, if the request size is going to, I mean that request body is going to be more than 2 MB, then it will consider that is an invalid request. That is optional. If you want to
Okay.
provide such kind of restriction, you can provide. Otherwise, you can ignore this one.
Yeah, fine. Thank you.
Right? And these properties, this is going to contains the right HMAC authorization header value into these four properties, and that header is also going to contain this four information: client ID pipe separated by pipe, signature separated by right nouns separated by pipe, and followed by this timestamp. So these four values I'm going to read from this header, and I'm going to store right with this. Next, what I'm going to do, guys, remember, does anyone having any idea related to data protection API in .NET Core? Anyone having any idea?
No, sir, we don't have.
Right. So basically, right, currently, right, if I want to tell you, please use some kind of right, encryption and a decryption mechanism. So what you need to do, you have to create your own custom class, right? You have to provide the logic for encrypting the data. You have to define the purpose string, right? All these things you have to do it manually. But what this ASP.NET Core provided, they have provided this data protection API, which is going to protect the data. Protect the data means what? That main responsibility of data protection API is to convert your plain text into encrypted format using a purpose string. Again, it can convert back that encrypted value into your plain text. That encryption, decryption, you can, as simple as it is, encryption and decryption. Right. So sensitive information, whatever you are going to store or retrieve, it you can store in encrypted format. You can decrypt the value right also using this data protection API. And more importantly, it is going to make use of purpose string, and that purpose string is going to make it as a robust mechanism. So it is not like a plain encrypted decrypted, right? Whatever the purpose string you provided, using that purpose string internally, it is going to generate a strong encryption algorithm. So for this purpose, what I'm going to do, I'm going to create one interface right within the security folder. That interface is going to define two methods. One is protect, another one is unprotect. And the protect method is basically responsible for converting that plain text into encrypted string. And this unprotect method is basically going to take the protected string and it will convert back to unprotect string, right? So let me go ahead and provide the implementation part of this class file. So within the same security folder, what I'm going to do, I'm going to create this security protector. So very simple, right? It is making use of the data protection API. So now what I need to do, you can see I'm using this iData protector. So this iData protector means it is the right. I can say this is the object that is going to be provided by .NET Core, and this protector method they provide some method they have provided. Now one is a create protector, right? Sorry, one is a protect method, another one is unprotect method. So first of all, what I need to do, I need to create an instance of this protector class. So how to create an instance of the protector? Now you have to call this, right. So basically you can see I'm getting an instance of a iData protection provider. So using this iData protection provider, you need to call this a create protector method, and you have to provide a purpose string. This value can be anything, right? But what is important now, whatever value I'm using, right, for encrypting, the same value I need to use for a decryption. So basically, using this data protection provider, I want to create an instance of the iData protector. Once I got the protector instance, then I can call this protect method to convert my plain text into right encrypted text. And while it is doing the conversion, it will make use of this right purpose string. So this purpose string, any string value, whatever you want, you can provide, right? But what is the benefit? It will make that encryption very robust, right? For example, whatever the encrypted value we are storing in the database, right? Whatever the encrypted value we are storing in the database, without this purpose string, right? No one can say or no one can identify what is its decrypted value. So that is the benefit of using protection API. And again, this will take the protected value, and it is only going to unprotect, right? Using the same purpose string, right? So if the purpose string is different, then he cannot unprotect it. So whatever the purpose string you are using, that needs to be used for both the protect and the unprotect. Clear?
What do you
So
call,
basically,
sir? Purpose string?
purpose string means what? It is a simple string. So for example, in encryption, decryption, we are using some kind of a salt, right?
Yeah.
It is very similar to the salt. Right? So
Okay.
basically, it will make your encryption very strong, right? No one can predict what will be the right? I mean the decrypted value. I mean to make your encryption decryption very strong, we need to provide a unique purpose string. So it
And
is
sir,
very simple.
same we are using to unprotect that same purpose string.
Yes, yes. Otherwise, it will not work. So whatever, for example, if I am using SAR 256, right? For example, if I am using one key, right? If you take the example of a JWT authentication, so whatever the token generation, while I'm generating the token, whatever the sign-in key I'm using while validating the token, if I'm providing a different sign-in key, is that going to work?
No, 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 sir.
Similarly,
Same.
whatever the purpose string I'm using, that needs in both protect and unprotect case. Otherwise, it will not work. So
Yeah.
this is very simple. It is going to do the encryption and the decryption. That logic I'm not going to use. That is this data protection provider provided by .NET Framework, and that's what I'm going to use. And it is a very robust mechanism. Next, what I need to do, I need to create some service classes and interfaces for our business logic. So let me first create one folder, that is services folder. So client service interface. So basically this folder is going to provide the method for client registration, client exist check, right? So these things are going to be handled by this method. So what you can see, uh, register async method. So we have to create some DTO. I have not yet created those DTOs. I will create those DTOs in some time. Right. Okay. So let me do one thing. HMAC option, HMAC parser, data protection implementation right now. Okay. So before service, let us first create the required DTOs, right? So it should be created inside the DTOs folder. So first of all, let me create one. I will come to this class file. So let me first create my DTOs folder. So this DTOs folder is going to contain the DTOs which is required for creating a new client. I mean registering a new client to our system. For registering a new client, whatever the data is required, that a client name is required, and rest of the thing going to be generated by my system. Client name I only need, and remaining client ID, client secret, all these things are going to be generated by the system. Once the client is registered, what information I need to return? Client ID and the client secret. So that's what I need to return. So for that purpose, I'm going to create this DTO. So you can see client and the client secret. This ID and secret that needs to be stored securely by the client. And this is another DTO. For example, I want to create one order. So this is for the testing that HMAC authentication. So with some request data, I'm using this DTO. So I will provide one create order controller with one endpoint which is going to create one order. Don't go with the data. So simply you can consider one DTO which is containing some properties, and that what the client needs to pass in the request body for creating a new order. So once we have these DTOs, right, next what I need to do, I need to come back to my client service. So basically you can see this register async method. So basically it is going to register a new client within the system, get active client. So based on the client ID, it is going to check, right, what is the client details. And based on the client, right, it is also going to get the client secret as input. So basically, whatever the client secret we are storing in the database, that is going to be in the encrypted format. And based on that encrypted format, I want to get the decrypted secret key. Right? So for that purpose, I'm going to make use of this method. So these are the three methods. Next, what I need to do, I need to provide the implementation. iClient service, go to this one, create a class file, API client service. See, if I want, I can do everything within the right, the middleware component. Why I'm doing this one? Because as for the industry standard. See, so this is the DP context instance which is required for doing the operation, right? What operation? Na database operation. And this is my iSecret protector. You can see this iSecret protector instance, which is providing protect and unprotect method. That's what I can call. So now registered method. So first of all, I need to generate a unique client. Suppose, right, whatever the value you want to store, for example, client, and you have to provide a new GUID. So this n means that hyphen is going to be completely removed. That the client ID, it is going to generate unique client ID. Then I'm generating a unit rate secret value. You can see this is a base 64 encoded value 40 what I can say 48 character secret value I'm generating here. So randomly it will generate 1 byte 48 bytes and then converting that into a base 64 string, and then this is going to be my client key, right? So this is going to be the secret, and this secret key is not currently whatever the base 64 string I'm getting here, this is in right, not encrypted. So this secret key is not yet encrypted. So now what I'm doing here, please observe, I'm creating an instance of API client, specifying the client ID, client name, and here you can see secret key, and I'm storing that encrypted version of this key. So this is a decrypted secret key. So what I can say, decrypted secret key, and then I'm calling this method which is going to provide me the encrypted version of this secret key, and that's what I'm going to store in the database. Clear? So I'm generating this secret key, but this secret key I'm not storing in the database. This secret key I'm storing but in the encrypted format. Whatever the encrypted value, that's what I'm going to store in the database, and then I'm calling this save changes method. And finally, once the user registered, I'm not going to return this encrypted secret key. I'm going to return this decrypted secret key to the client. Clear? Clear, guys? And this decrypted secret key will be used, right, when I'm doing the when I'm generating the authenticate HMAC token. So for generating the HMAC signature, I want the decrypted version of the secret key, not the encrypted. But in the database, I'm storing the encrypted value, and I'm returning that decrypted value to the client. Why? See, so whenever you are right, registering within the system, whatever the password you are providing, that password you are providing in encrypted format or a plain text?
Plain text.
But in the database, it is going to be stored in which format?
Encrypted format.
Encrypted format.
So
Hashed
that
or
is not
Hash,
encrypted, that is
hash.
going to be hash value, right?
Yeah.
But here, what we are doing here, now we are doing in a right, in a different manner. What is that different manner? Now we are returning this encrypt. We are returning this decrypt. We are creating this decrypted secret key. We are returning this decrypted secret key to the client, and we are storing the encrypted version in the database. Why? Because no one should identify, right, what is the secret key, so that if anyone got this plain text value, then if a hacker got this what I can say, if they got this one, they can generate write the request and send the request. So this secret key, what I'm returning to the client, that is going to be shared in the client machine. This secret key will never be transferred, right, between the request, right? Only this right, client ID is more than sufficient, and from the client ID we can get the client secret. Yes, at the time of a login registration, that is a different thing altogether. I'm not this HMAC authentication is not meant for your authorization server, guys. Remember, authorization server is different, and this HMAC authentication what we are creating, this is specifically for our resource server, right? We want to validate the client. So that is the reason why you can see this is going to be client ID. This is my decrypted secret key. I'm storing the encrypted version of this secret key in the database, but I'm returning this decrypted value to the client. And the client, when it is going to generate the HMAC, he needs to use this decrypted secret key. And again, in the server, when I'm regenerating, I also need this decrypted version. And that is the reason why I'm not storing this in the hash value. I'm storing it in the encrypted value, so that, right, once I got this once I got the client ID, so based on the client ID, I can got the encrypted secret key from the database. Once I got the encrypted secret key, then I can call this on protect method, which is going to return me which is going to return me the decrypted version of the secret key, and that decrypted key I can use right for the validation purpose. Clear?
Yes, clear.
Right. So as long as it is very simple, while I'm generating the HMAC, whether it on the client side or whether on the server side, I have to use that decrypted secret key. That is as simple as it is. But in the database, we are storing the encrypted version. Clear? How we are going to get the how we are going to convert that decrypted secret key to its sorry, how we are going to convert that encrypted to decrypted secret key, we'll see right while we are generating and validating the token, right? So for now, it is right. That is what we are doing. We are creating a client with the encrypted secret key, but we are returning that decrypted secret key to the client. So when the client register into our system. So this endpoint mostly from your internal panel, admin panel, you need to invoke, not from your public API. So next, get active client. So here you can see whatever the client ID we are getting in the request header. So based on the client ID, we need to check whether that client exists and active or not. So if that client is existent active, that client information we are providing. And here, right, again, right, one more changes we can we can do here. Now, instead of using this API client, so what I can do is I can make use of string client key. That also makes sense. String secret key. API client service. So here is my API. So why I should pass that complete client object? I need only that secret key. So only I can pass that secret key. Then what I need to do? Now here, instead of this one, what I can do, I can got the secret key, and that secret key I can pass here. So here I'm getting that right. What I can say, uh, encrypted secret key. This is even if you
Client secret
right.
key.
See, that is client secret. See, here secret key means a client secret key, right? So once you got the client secret key, and right, and from where you will get this one. Now, when I call this get active client method, it will return me client ID, API client, and that API client already contains this encrypted secret key, right? And that encrypted secret key will receive as a input here, and it will protect and it will return the decrypted secret key. So better naming convention is good always, right? Decrypted secret key. And that decrypted secret key we are returning from this method. Clear? So in simple sense, you can also call this like encrypted secret key. And this is going to be your encrypted secret key. So here you can also give the same name like this. Clear? So proper naming convention, right, will right most of the time solve your queries. So here I'm getting, so this will return the complete client along with the encrypted client's secret key, and that encrypted secret key we are receiving here as input, and right, that what we are again if you want to make sure, right, you can also provide this value as something like encrypted secret key. Clear? If you are getting confused on secret key and encrypted secret key, let's do this in this way only. Clear? And here what I need to do, I need to use encrypted secret key. Clear, guys? Clear or not?
Yes.
Yes.
Right, so this method going to register a new client, it will return the client details, and from this client return one of the properties encrypted secret key, and from the encrypted secret key, right, what we are going to return, we are going to return the decrypted secret key. So this is the method of API client, right? So next what I'm going to do, this is API client service is done. I will update and I will provide the updated code, right? So whatever the changes I'm doing, I will give you the updated code only. So IHMAC header parser. So this is going to be IHMAC header parser. So you can see in the security folder, I have created one class file which is going to store that client ID signature, nonce and timestamp value, which I'm getting in the x-hmac authorization header. But who will do this conversion? So taking the header data, converting that data into my HTML header, HMAC header, HMAC past header. So for that purpose, what I'm going to do, I'm going to create one service class. I'm providing one interface, i.e. HMAC header parser. So this HMAC header parser going to have one method, and that method will take that string, and it will write that header value. It will string separated by pipe symbol, and it is going to return that HMAC right past header, that instance what we created here. So let us proceed and implement that class. So go ahead. Are you getting, guys, what exactly going to be the role of this class file? Right. So basically, in the client, when the client sends the request, it will send the request in this format: client ID, signature, nonce, and the timestamp value. So again, when the right from the middleware, we will call this try parse method. We'll pass the header what I'm getting from the right HMAC authentication header, and I'm also going to provide this output parameter. So this output parameter, let us first initialize to avoid runtime error. So I'm initialize this with this new keyword with the default values. Then I'm starting the parsing. So first of all, I'm going to split this value. This is a string value. Split by this so that I can get the parts. If parts is not equal to 4, so 1, 2, 3, 4, then I'm going to return false. If so basically, it this long dot it basically this parts it is going to be an array, and validate the parts and timestamp portion must be unique. So basically, what exactly it means? So inside this part, so this is the 0th index position. This is first index position. This is second index position. This is index position 3. So index position 3 contains what value? It contains the timestamp value. So basically what I'm doing here, that timestamp must be a Unix value. Unix means what? It is going to be integral long value. So what I'm doing here now, whatever the timestamp value I'm getting, is this convertible to long type? If it is convertible, that is fine. Otherwise, return this one. So this is going to validate whether the fourth parameter unique timestamp it's a valid value or not. If it is valid, then get the first part, get the second part, get the third part, and get the fourth part, right? And once all this part are done, then we need to check whether every part contains the data or not. So only if every part contains the data, that is client ID, signature, and nonce, then we are going to return true, right? And again we are going to return true or false, and that value are already populated with this output parameter. So from this parameter, if it returns true, then we can access the output parameter, and from this parameter, whatever the value we set here, like a client ID, signature, nonce, and a timestamp, you can access and you can use within your code. So how to use, I will discuss. So next, what I'm going to do,
Hello.
yes.
Yeah, we are checking at the end everything like client ID, signature. So and we should be using the like
See, basically
this.
what we are telling here, right? See, at the end, see here we are populating. After populating, so this is a boolean, this is a method which is going to return boolean. So I need to return either true or false.
Yeah.
So what I'm checking, if
Okay.
client ID is null or empty, if
Yeah.
signature is
Yeah.
null or empty, if nonce is null or empty, I need to return false. If
Got it.
any of this value is null or empty, I need to return false. Otherwise,
Yes.
it will return true. And why I'm not including the fourth part, What I can say, the unique timestamp, that I have already checked here,
Yeah. Understood.
right? Yeah. Next, what I'm going to do, I'm going to create a service class for handling the nonce value. So storing the nonce value into the database, checking whether that nonce is already used by the client or not. So for that purpose, I'm going to create one class file, one interface, that is inonce service. And let me first define the interface. See, so is nonce used async? So for that particular client, it is going to check whether this nonce value is already being used. If it is used, it will return true, otherwise false. Then try store nonce value. So this, if it is not being used, then what exactly it is going to do? It is going to store that nonce value into the database. And this is basically going to, I will provide one date time. And accordingly, how many nonce values are there as per this date time value, all those are going to be deleted from the database. And this method is going to be used right within our background service. We are also going to create that background service. Next, what I'm doing here, I'm creating my nonce service class. This is going to be very simple class file, you can see. So I'm taking this DB context. I'm checking, right? Whatever the nonce, I mean datetime.now I have provided here. Check if the nonce is already exit for this client. So whatever the nonce value I have provided, right? And here you can see expiry art. So basically when I'm storing a value, I'm also setting the expiry UTC value. So if this expiry UTC is greater than the current date time, that means this nonce is no longer, I mean, this is that time is expired. So basically what I'm doing, I'm checking for this particular API client and for this nonce, is there any data exist, any valid data exist or not? If valid data exists, it will return true, otherwise it will return false. Next, this is the method which is going to store the data. So here you can see API client ID, nonce, timestamp, and when it is going to expire. So that information it is going to store in the database. If it is successfully stored, it will return true, else it is going to return false. And this method is basically going to delete. So whatever the data in this table, and whatever the expire time, if that expire time is less than this time what we provided, then this execute delete async method exactly going to do a bulk operation. So basically, instead of fetching the data from the database to our application, where we are going to manually set data deleted property, I mean that entity state to deleted. So directly, if we call this a execute delete async method, so what exactly it is going to do? Now, whatever data satisfy this condition, so those data it will directly going to delete in the database. It is not going to fetch those data to our application. It is going to do all these things right directly in the database, which is going to definitely improve your application performance. Clear?
Yeah, okay.
So this is the advanced things that what you need to understand. So next will come our HMAC signature service class, right? So for generating the HMAC signature, whatever the methods are required, right? How you are going to generate. Again, we are going to create one service class. So here you can see computed body has base 64. So basically what exactly it is going to do. Now it will take the request object, and this max byte what you already discussed right in the HMAC option class, maximum how many bytes. Accordingly, you will decide right whether to proceed or not. So that validation if you need you can put. So this what exactly this is going to do now, whatever the request body, so it will convert that request body into its a hash. So basically whatever the request body, it will convert that request body into a hash string, and that hash string it is going to return. And again, from where we'll get the request body? From the HTTP context object. Then this is build string async method. So basically this method is only responsible for converting the request payload to a string. So this is going to define, right? Actually, it is also going to return a string. That string is nothing but your HMAC string. So this HMAC string is going to contain the method type, URL, path, request body, nonce, timestamp, everything, right? Whatever the data is required, that string is going to be written by this build string to sign method. And the computed signature of base 64 method. So basically what exactly this is going to do, now it is going to write, so basically whatever the string is generated by here, we need to provide the secret key, and this string what this method is returning, using this secret key, it is going to generate our HMAC signature. So how it is going to do, let us try to observe. So now I'm going to create my last service class, HMAC signature service. So this not this one. Okay. So this is not the implementation. Okay, let me copy my implementation. Okay. So please observe. So computed body has a base 64 string. So first of all, what we need to do, we need to check what is the content length If it is greater than whatever the max byte, so request body too large for HMAC processing. That's what I'm returning. If you don't want this logic, right, you can also ignore. So enable buffering means what? Now currently we are reading, right, while doing the HMAC validation, we are reading the request body, and in the downstream, right, middleware component, for example, when it is going to do the model binding, when it is going to, again, it is going to load the data from the request body. So do you want to allow that request body to be read multiple times? If yes, you have to enable the buffering, right? Then again, what I'm doing here, now I'm loading that request body using this memory string, and then I'm right, converting that memory string into byte array. Again, I'm resetting that position to 0 so that any middleware controller component, they can also start reading from the first position. So once we have the byte array, then what I'm doing here, please observe, I'm converting that byte array into a hash value, and that base 64 representation of that hash value I'm returning here. So it's very simple. Whatever the request body I'm reading from the HTTP context object, converting that request body into a hash value, and then that hash is going to be very difficult to understand. So what I'm doing here, I'm converting that hash into base 64 encoded string. So why I'm converting this? Because it is safe to transfer in the internet. So when you are sending some data, and if that data is going to be transferred, hash is not safe, right? So always this is 60 base 64 string is going to be safe. So that is what I'm doing. So basically this method computing the hash rate of the request body. So then this is my method which is taking the request object hash body. So what this method is returning, that is going to be the input for here, nonce value and the unique second. So now first of all I need to identify what is the method type. HTTP port, what is the method? What I'm getting from the HTTP context method that to upper variant. So in this case, that put you have to provide in uppercase. Guys, remember uppercase, lowercase, any small case mismatch, it is completely destroy your HMAC signature. So caching is very, very important. So here I'm generating this method, right, HTTP method into uppercase. This is my path and query. So what is the request path? Any query string parameter, I'm preparing that path and query, and this is going to be my HMAC string. So how it is going to formatted? Now what is the HTTP method? Then it is appending this path and query. Then it is appending this request body hash. Then it is appending my nonce value. Then it is appending my unique second value, epoch value, right? That timestamp value. So once it is appending, this is going to be my HMAC string, not HMAC signature. This is going to be my HMAC string. So in first case, I'm getting the hash body. In the second case, I'm getting the HMAC string. And in the third thing, right, whatever the HMAC string is written, that is going to be the input along with the secret, right? And this secret, right, you can say this is going to be your decrypted client secret. So that's what the meaning. Decrypted client secret, right? So that's what I'm getting here. So decrypted client secret. So I'm converting that decrypted site client secret into bytes array, and then right, I mean bytes, and then I'm using that bytes array to generate my HMAC algorithm. So how? Now first of all, right, you can see this is going to be my bytes array, and this is also what is the right. So basically you can see I'm converting. So whatever the decrypted client secret, that what I'm converting into array, and this signing string, right, that what also I'm converting into byte array. So here that secret key bytes, and here so decrypted client secret. So give meaningful name, decrypted client secret bytes, and this is going to be your sign to right string to sign bytes. So that what I'm converting here, and this value to values I'm providing here, and this is what I'm providing here. So once I convert my decrypted client secret to byte array, and once I convert my sign to string, right, to byte array, then I'm creating an instance of my HMAC algorithm. You can use 256 or 512. So whatever the algorithm you use, that is going to generate a fixed length value, right? So I'm creating an instance of a HMAC algorithm using that secret key. And once the HMAC, once that HMAC instance is generated, I just need to call the compute hash method. And to this method, whatever the right sign in key is, right, string to sign in value, that's what I need to pass. It is going to return me a byte array, and that byte array I need to convert into a base 64 string, and this base 64 string going to contains the HMAC signature. Clear? Clear, guys?
Yeah, clear.
So once this is done, next what I need to do, I need to create one middleware component. So that middleware component, right, is going to validate the HMAC signature when the request received by the system, right? So let me go ahead and create one class file. That class file name is going to be HMAC validation middleware. So it is very simple. Let me go ahead and implement this one. All the logic we have implemented, this is just needs to put them in a proper sequence. So let me go ahead. Okay. So, you know, a middleware component means I need to provide the delegate which is going to be execute next. The next delegate that needs to be executed in the request processing pipeline. I'm going to log some important information. That is the reason why I'm also injecting logger. So now this is the invoke async method that is going to be invoked by the framework automatically. This is HTTP context object to get the context details. This is options pattern to read the HMAC settings from app settings.json file. And these are my 4 service classes, right? One is for converting that HTTP request header to a strongly typed class. This is for dealing with the signature, HMAC signature. This is for dealing with the client, and this is for dealing with the nonce. So now what I need to do? So first of all, I just call option.value so that if any value is changed in the app settings.json file, that updated value you will get from here. Now, if HMAC is enabled, so this is going to, this option means, what I can say, close other tab. Okay, so this option is nothing but this class. So from this class, this enabled property is there. So if HMAC is enabled, we will proceed. If not enabled, then just call the next middleware component, and from here just return. You do not need to do anything else. If HMAC is enabled, then what I need to do? Then I need to read the path, right? Context path. What is the path? And whatever the path I read from the HTTP request, is that path available in this skip path list? If that is available in this skip path list, then I don't need to check the HMAC authentication, right? If it is available, right, within this, then just call the next middleware component and return. If it is not available, then what I need to do? I need to check, right, whatever the HTTP header we specified here, is that header is available in the HTTP request? If it is available, that is fine. If it is not available, then reject the request and return this missing HMAC header. And this reject method, it is a custom method we created here, which is going to return whatever the status code we specified. Content type is going to be this one. Whatever the error message we specified, that what it is going to set in the response stream. So basically, in this case, you can see context object. We are going to return 401, and this is the message. So 401, this message it is going to return. So now if the HMAC header is available, then what I need to do? I need to parse the HMAC header value. So we have this what I can say, header value. So here we can see ensure, right, if the HMAC header is available, then that value it is going to store inside. But here it is going to store that value in this format, client ID signature non-string. So now what I need to do? I need to convert this value into this type. So for this purpose, what we have created one class file, HMAC header parser. So this class having this try-parse method. And that method I need to call parser.try-parse. What is the header value? That what I'm passing, and this is going to my output parameter, HMAC header. So again, if this validation is true, it will return true, and that object is going to be populated. Else, it is going to return this invalid HMAC header format. The next one is from Unix time in seconds. So basically, what I need to do? I need to check, right? Timestamp is used to limit the reply attack. So basically, what exactly it means? Now, whatever the header, whatever. So from this HMAC header, so from this header, I got the timestamp. So whether this timestamp is allowed, right, within our allowed clock end or not. If that is within the allowed clock end, that is fine. Otherwise, we can return timestamp outside allowed window. So basically, whatever the window is set, right, you can see this allowed clock window is set, and accordingly, is this request is valid or not? That's what I'm validating. If it is after 5 minutes, then it is going to reject the request. Then if everything is fine, next what I need to do? I need to, I have already got the client ID. right, in the request header. So based on this client ID, right, any client is exist. So that's what I'm checking. And here you can see this method is already implemented, right? It will take the client ID and it will return me whether the client exists or not. If it exists, that client object it is returning. If it is not, then we can return this unknown or inactive client. Then if we got this client, then we need to check whether that client secret is expired or not. If the client secret is expired, so we need to tell that your secret is expired. So please regenerate the expire or something like this. That error message we need to return. Otherwise, if that secret is not expired, right? Then what I need to do, I need to check whether for this particular client ID, right, and whatever the nonce value I'm getting, whether that nonce value is already used for this particular client. If it is already used, then I need to return this message replied. Clear? Till now clear, guys?
Yeah, Chris.
Right? So if everything is fine, then what I need to do, I need to compute the hash body, right? So for example, whatever the request body, so that's what I need to compute. So how you can do this? Now for this purpose, right, we are already have created this HMAC signature method. So this method computed hash, I need to pass the HTTP context object maximum byte size. So that maximum byte size we are getting from our options pattern, and that HTTP context at request at what I'm passing, it will return me the hash body. If any error occur, then we can return this hash, right, HMAC body hash is failed, right? If I'm not getting any error, then I will come to this part. So again, in the second step, what I need to do, so once I have the request body, then I need to build the right signal, right, HMAC string. So how you can do this? Now by calling this method. So to this method request body has nonce and a Unix timestamp. That's what we need to pass. So this is my HTTP context object. This body I have got in the previous step. Whatever the request header, right, that nonce value and the timestamp value we have already faced. So that's what I need to pass. And this is going to return me the HMAC string in this format, right? So once I have the HMAC string, right, next what I need to do, I need to get the client secret. So how you can get this? Now for this method, what I need to do, I need to call this right, client dot encrypted hash key. So this client dot encrypted hash key, it will return me the decrypted secret key. It will return me the decrypted secret key. And if this decrypted secret key is not equals to null, then we'll proceed. Otherwise, we can return this message. So if the decrypted secret key is available, then what I need to do? I need to generate my signature. And for generating the signature, I need to call this method, right? So that's what I'm passing. So whatever the string we generated and whatever the decrypted secret key, right, we got here. So that's what I need to pass, and it is going to return me the expected signature. So let me give this full name, expected signature. And if this expected signature is matched with the right signature that what I'm getting from the client, that is fine. If it is not matched, I need to return this error message. Clear? Till now?
Yeah, clear.
Right. If HMAC signature validation is done, next what I need to do? Next, I need to add that nonce into the database. But what is the expire time? That what we have already defined in our option button. Say in the option button, nonce to detail. So 10 minutes. So what I'm doing here, you can see now whatever the request time. So right to this request time, I'm adding 10 minutes. So that is going to my expire UTC. So once I set the expire time, then what I'm doing, I'm calling this a try store nonce method. So this method is going to store this one into the database. So once that nonce value is stored, right, I'm checking whether it is rate stored or not. If it, most of the time it will be stored. Why? Because at this point of time, we have already checked, right, that nonce is I mean that is valid one, right? So because that checking that nonce, we have not yet checked the nonce. Yes, it's nonce is that what we have already checked. So at this point of time, 100% it is going to be a valid one, right? And then in the context object, I'm enriching my client added client name. This is optional. If you want to store a right data client and client secret in the context object, you can store and finally call the next middleware component. Clear?
Yeah, clear.
Right. Next, what I need to do, I need to create my background service, right, which is going to run in the background to delete the unused nonce values from the table, right? Because we need one mechanism. So let me create one folder, background services. And within this server, I'm going to create one class file. This is going to be a background service class. So let me create this class file. Okay. So here you can see as this background service, it is going to run like a singleton service. So you cannot use scoped services either, right? So you cannot inject a IDB context kind of things, or I, or whatever services with scoped is a lifetime is scoped. You cannot use them directly. So here what I need, I injected my service provider. So using the service provider manually, I can create the right scoped instance, right? So this is the execute async method, which is going to be execute automatically when your application starts. Until and unless your application is not stopped, it will continue. How it is going to continue? First of all, I'm creating a scope object, and using this scope object, I'm requesting to get an instance of this right nonce service. So this nonce service instance I'm requesting. So this method nonce service request I'm requesting, and here you can see I have defined one method. So once I got the method, what I need to do, I need to invoke this method by passing the current date time. So as per the current date time, right, whatever nonce are there, which expire time is less than the current day, I mean less than the current date time, they are going to be deleted automatically, right? If deleted is greater than 0, so it is going to tell this one. And if any error occur, that will be logged here. And once this logic is executed, when the next logic is going to be executed, after 10 minutes. Right? So this is a while loop, and every time it execute, it wait for 10 minutes, and again in each 10 minutes, this loop will continue its execution. Clear?
Yeah.
So next, what I need to do, I need to create one controller for the client registration, right? So what I'm doing here, please observe. So I'm creating a controller here. So within this controller class, create a class file. So this is going to be my controller. So this controller is going to provide one endpoint for the client registration. So the client can register. I mean, this is not going to a public endpoint. It will be used internally by the admin. So one endpoint is just for the testing purpose. So whatever the client registration detail, that client name it will provide, automatically client ID secret are going to be generated. And then that client right ID and the, so this decrypted secret, it is going to return DP. So, okay, instead of saying decrypted, please put it as a secret only, right? That the secret it is going to return to the client. Next, I want another controller that is going to be my order controller. So this orders controller, it is going to be protected with a HMAC endpoint. So let me go ahead. So this endpoint is a protected endpoint. So if I want to access this resource service, then I have to provide a valid HMAC. That HMAC token is going to validation is going to be there. So here you can see I'm not writing any logic. So here you have to remember this endpoint is protected with HMAC. If I'm not sending invalid HMAC, then this method is not going to be execute, right? So this is going to my create method. Next, what I need to do, I need to provide the configuration details. So first of all, go to the app settings.json file. So specify the database name, HmacAuthDB. So the database is going to be HmacAuthDB. And here you can see I'm providing a null true. Header name is this one. Allowed clock window is going to be 5 minutes. Nonce value validation is going to be 10 minutes. Maximum body is 2 MB. What path it is going to skip? Swagger path it is going to skip. And API client register, right? That client register endpoint what we provided, API client. So for these two endpoint, that HMAC authentication validation is going to be skipped. If you make this one false, then it will be for all the endpoints. Next, what I need to do, I need to register all my services to the application processing pipeline. So let me go ahead and do this thing. See, I'm registering my controller services. Also, I'm disabling the naming convention, right? Camel case naming convention. So this is going to be, I'm registering my DB context. So this is important for the data protection. So you can see I have used this iSecret protector. Here you can see I'm using this iData protector, iData protection provider. So this to work, you have to enable this service. This service will provide that data protection to your application, which you can use for encrypting and decrypting the data. And this is the options pattern, which is going to read the HMAC section settings. So this HMAC sections value it will read, and it is going to populate this HmacOptions class. Then I'm registering my scoped services, iSecret provider, I application right service, I nonce service. Again, you can see I right this HMAC parser and right, and this HMAC signature. I generate them as singleton. Why? Because they are these two services. You can say I HMAC header parser. Is this going to deal with any database? No. So it is online, inline. Inline means there is no database involvement is there, and the logic is going to be same. So that is the reason why I make this service as a singleton service. Also, you can see this IHMAC service, right? This HMAC. Even right here also, I'm not going to dealing with any database logic, right? So if this service class doesn't have any relation with the database, so we need to mark them as a singleton for better performance. That is the reason why these three are dealing with the database, and these two are going to be this protection. It is that I data protection API that what I'm using, that is scope. That is the reason why I'm using this as a scoped service. This IAPI client and iNonce service, they are going to deal with the database. That is the reason why I declare them as a scoped service. These two are not going to deal with any database. So it is safe to declare them as a singleton. And this is going to my background service, which I need to register using this iHosted service. As soon as my application start, when this application start, automatically this background service is going to run in the background. And then what is important? You need to register this middleware right to the application processing pipeline. So this will check, this will validate your HMAC authentication. So once this is done, let me first build the application to ensure there is no compilation error. Nothing is going to be there. Okay, so there is a error. So secret key. So this value we have changed this to decrypted secret key. So this is going to be encrypted secret key. In the database, we are storing that value in encrypted format. So that's what we are doing here. Now again, build the solution. Okay, build successful. So one build successful. Next, what I need to do? I need to generate my migration file. So R migration. Let me check. HMAC author DB, is there anything? Okay, HMAC author demo DB. So it should create that HMAC DB. Okay. Next, I need to execute my update database command. Okay, so database is created. Now you can verify the same here. So HMAC author DB. So this is the database. And in the database, you can see two tables. One is the API clients table, and another one is the API nonce table, right? So now what I'm going to do, I'm going to provide the client registration, right? So for client registration, you can see I can directly run the application. This client registration endpoint is protected with HMAC or not, guys?
Not
This client registration endpoint, what I have created here, is this endpoint is protected with HMAC?
No,
Why? Because
because we
that
have
what
saved.
we have specified, that I'm not going to provide any kind of a restriction, right? So now what I'm going to do, I'm going to create a client, right? So for this purpose, what I'm doing, I'm going to this one. I'm specifying the client name as a demo client 001 and execute this one. So once I execute, I'm getting this client ID and a client is secret. So these two values I need. So this is the client ID and this is the client secret. So these two value client will use, right, for generating the HMAC signature. Here now, if you look at this endpoint, create order. So is this endpoint required, right? Some kind of authentication.
Yes. Mm,
So, right. So what type of authentication? Some, right? Let assume it is going to have some unique number, amount, currency is INR, right? Some customer ID is going to be CUSD, right? Some 111. So now this endpoint is protected with HMAC. Why? Now we have not provided that list here. So HMAC validation will come into the picture. Now execute this one. So what I'm getting here, missing HMAC header. So now you are not passing any HMAC header. That is the reason why you are getting this error. So now what I'm going to do is I'm going to develop that client application. That client application exactly in this case is going to be any client, can be anyone. It can be Angular application, React application, Android application, iOS application, another MVC application, another web API application. It can be a desktop application. It can be a console application as well. So what I'm going to do is I'm going to generate a .NET console application as a client, and I'm going to show you how you can generate that signature, right? And how you can pass that signature in the header, and how that replay and all these things are coming into the picture. If one signature I generated, if I'm reusing the same request with the same signature, right? Whether that is being right accepted by the server or not, that what we are going to discuss. So first of all, what I'm going to do, I'm going to create a console application. So HMAC client app. So open your Visual Studio again. So this is a different project I'm going to create. So this time it is going to be a console application. So select the console tab from here. HMAC client app I'm providing any name you can give. So create this one. What is important? Important is the same structure, same approach you need to follow. The way you are generating the HMAC in the server side, in the same way you need to generate the HMAC in the client side. And to work with this, to work with HMAC, what we need, I need two pieces of information. So what information I need? I need this client and client secret, what we have already generated. So these two information you need. So without these two information, you cannot work with the HMAC authentication. And we have already these two information. So now let us create a helper class. And this HMAC helper class is responsible for generating the HMAC signature. So create a class file. Already we have discussed the logic. I'm not going to take more time. Simply I'm going to explain the same logic one more time. So this is going to my helper class. See what I'm doing here. I'm generating a nonce. So for HMAC authentication, what are the information I need? I need the client ID. Yes, I have the client ID. You can see that the client ID is already with us. This is my client ID. I need to generate that HMAC signature. What I'm going to generate. Then I need two more information. What are the information I need? I need that timestamp and the nonce value. So client ID, I have signature, I will generate. Nonce value, I need to generate. Timestamp, I need to generate. So first of all, you can see I'm having this method which is going to generate a nonce value. This is my get unique timestamp. So this is going to generate the epoch time, the unique time in seconds, right? So whatever the current date time, so it will generate the epoch value that is going to be in the long value. So till 1971, till current, right? At the time of when this statement is executing, how many seconds are there? That seconds is going to be in integer format. That number of seconds, right? That what this is going to return. Then this is the method which is going to compute the body. So whatever the request body, that what I'm going to pass, that hash value I need to generate. Again, that hash I need to convert into, right, what I can say base 64. So first of all, I'm generating the byte. From byte, I'm generating the hash, and that hash I'm converting into string. So now if you go to your application, right, in HMAC. So if you look at this HMAC signature service. So how I'm generating the hash? So first of all, I'm getting I'm getting that request body in bytes, and I'm converting that request body bytes to a hash, and then I'm converting that hash into base 64. Now, in this case, I'm getting that request body from the HTTP context storage. But technically, if you see, three things is happening. Whatever the request body, convert that into byte array. That byte array hash value you need to generate, and that hash value you need to convert into base 64 string. And the same approach we need to do here. And here we are having the request body that is going to be in string format. So just convert that string into byte array. Once you have the byte array, generate the hash value using the same algorithm, whatever is being used in the server. In server, I'm using SHA-256 means the client needs to use the same SHA-256 algorithm and then convert this into a base 64 string. Clear? That same logic I'm applying here for converting that request body to hash. Is that clear?
Yeah, clear.
Right now. Now, in this case, you can say I'm preparing the right HMAC sign-in string, which is going to contain method, path, and query. Now, coming to this part, so this is my method. Whatever the request method I'm getting as input, I'm converting that into lower right uppercase. Why? Because the same approach I'm also applying here. Method that is going to be in uppercase. So again, here I'm doing the same thing, that I'm getting the method, and that method I'm converting into uppercase. Second one is path and query, that is going, I'm receiving as input parameter body has, that what I'm also going to receive, then nonce and the timestamp. So whatever the data is there, so in this format, right, I need to prepare the string, and the same what I'm doing here. Clear? So the process, right, the sequence, guys, remember, if you put this one first, uh, then this one, and after then this one, it will not work. The same sequence is required. So how you are providing the path, method first, then path and query, then body hash, then nonce, then Unix in seconds, right? The same approach you also need to follow in the client side. Clear? Clear, guys?
Yeah, clear.
And finally, what I'm doing here, I'm generating the right, what I can say, signature. So first of all, uh, I'm converting that decrypted client secret into bytes, then converting that right sign-in string into bytes, then creating an HMAC object using this decrypted right client secret. Now come to here. So here I'm already having the decrypted client secret. So whatever the client secret I'm receiving here, that is in the right what I can say base 64 format. So simply directly you can convert to byte array. And right, that step is already I'm doing here. I'm converting into this byte array, and here what I'm doing, I'm already receiving that in byte base 64 format. So from base 64, I'm converting into byte, and from bytes, I'm converting into bytes array, and then I'm generating the HMAC algorithm, and then I'm calling this compute hash method similar to this one. So the way I'm creating the HMAC instance, the way I'm generating the hash, converting that hash into base 64, that same approach I'm also following here, right? So once this is done, next what I need to do, right? Next you need to observe, right? One more thing. So in the order controller, if I want to invoke, then I need to pass one instance of this class. I mean, I need to create a JSON object, which is very similar to this structure. So to keep the same structure, right, what I'm going to do, I'm going to create a DTO in the, right, what I can say, client side. So here I'm creating another DTO, and this DTO is very similar to the DTO what we defined in the server. So let me create this one. So this is going to be my DTO. So that's it. So we have done the implementation. Only thing is remaining that the program class code. So go to the program class code. So here few changes I need to do. Right, let me start. So what is the endpoint on which your application is running? It is running on 7001. So that's the base URL you need to set here. So this is my endpoint URL, base point plus endpoint URL. This is going to my full URL. I need this client ID and the client secret. These two value I need. So which I already right. So this is going to my client ID. So copy this one. So this is going to my client ID value, and this is going to be my client secret value. So these two value I need to copy. This is my order request DTO or whatever the references. So don't go with the logic, right? Whatever the data you want to pass, you can pass. This is my .NET object. I'm converting that into a JSON string, and that JSON object I'm printing in the output. Then I'm generating the nonce value. I'm generating the timestamp, and I'm generating that hash of this request body. So once I have nonce timestamp body hash, I already have the right client secret and endpoint. So right, you can see endpoint. All these things I have. So request method is going to be post. This is my endpoint, body has nonce time. So all this thing I passed. So that sign in token is going to be generated, sign in string token. Then I'm using my secret and signing to generate my signature. So once the signature is generated, I'm specifying the HMAC header value. That is going to be whatever the client ID. This is going to my signature. This is nonce and this is timestamp. And this is going to my HMAC header value. This thing I have also printed here. Then what I'm doing, I'm creating an instance of HTTP client class and I'm sending the request, right? When I'm sending the request, I'm calling this a send request async method, right? So now this is my send request async method. I'm HTTP client object. What is the URL, body, and HMAC header? That's what I'm getting. So I'm creating an HTTP request message object. I'm specifying it is a post request. Whatever the URL you want to invoke, whatever the body, that what you need to specify in the body. Then I'm going to append the custom header. So here you can see that header name is this one, and whatever the value I'm receiving, that what I need to specify. And I'm sending a request to the server. I'm reading the response body and I'm printing that response body into the log. And here you need to observe two things. So this is my first request. So when I send the first request, my expectation is 200. But if I'm sending the same request again here, what the server will understand. So let's assume this is going to be sent by the hacker. Then if the same request I'm sending, you can see same HTTP client, same URL, same request body, same HMAC signature. If I'm sending everything same, then at this point of time, what is my expectation? Should I get the response or should I receive that it is a reply attack? Clear? What should I
Yes.
get? Now let me run the application and see whether it is working as expected or not. See? So first request, I'm getting 200 status and this is the message order created successfully. Second request, I'm getting what? HTTP 401. And what error I'm getting? Reply detected. Clear?
Yeah.
Yes.
Right? Now when I'm sending the request, right? When I'm sending the request, am I passing my client secret in the request? No. That client secret, what I'm using only for generating the signature. I'm only passing the client ID and server know for this client ID how to get the client secret. For this client ID, he already stored the hash right encrypted with that encrypted secret is there in the database. That encrypted secret is retrieved from the database. Again, that he will decrypt that value. Once it got the decrypted value, he will generate the HMAC again, and then it is going to compare. So this is how HMAC authentication is working in real-time applications. Clear?
Yeah, clear.
Right? Anyone having any question, guys?
Hello, sir.
Yes.
Not directly related to what we're doing right now. I was just wondering if you're gonna be teaching us OAuth as well.
Yeah, we'll discuss. So why were in a hurry? We have started authentication and authorization. We have not yet discussed identity. Both we are 100% we are going to discuss, right? How to integrate with the Google, how to integrate with Facebook, right? How to
Okay.
integrate with Microsoft. All these things we are going to discuss.
All right, sir.
Practically, clear? No. Anyone else having any more question, guys?
Sir, it is possible if the hacker sends a request and then he send the request to server, then what will happen?
So what I'm showing here, if the hacker got the request, means this information hacker got.
Yes.
And if the hacker sending the same request, then what response you will get?
Yes.
Got it?
Yes. It is also possible to get the first.
Sorry, what? Your voice is breakable.
Means it is possible to also get the first request by the hacker.
First request, if hacker got right, what is the meaning, right? For example, I'm sending the request. If the hacker sees the request and if the hacker doesn't do any changes within the request and send the same request, does it make any sense to the server? I'm sending the request. In between, you just see the request, but you do not do anything else. And that same request is transferred to the server. Doesn't make any any kind of a issue right to the client and to the server.
Okay.
Right. So only issue. Right. For example, this logic I have executed, one money transfer successful from one account to another account. If I'm sending the same request, if that request is again accepted by the server, again that transfer will be happening. So that's what we need to restrict.
Okay, sir.
If the hacker making some changes instead of your two account, he is providing his own account. So that we need to restrict, and that what we are right. That is going to handle easily. Any changes in the request body, request rejected. Once it is processed, again if you want to send the same request, that is going to be handled by the application. Right, for
sir.
sometimes what happens, right, if you know don't know, right, sometimes when you double click one button, right, sometimes two requests, right, same request coming to two times to the server. So we need to handle such kind of scenarios using this HMAC.
Okay, sir.
Clear, guys?
Yes, sir.
Anyone else having any more question, guys?
Yeah. Hello, sir. When you send the same request after 5 minutes, will the server accept it?
Sorry, after 5 minutes.
Yes.
So after 5 minutes, if you will send this same request, right, then what will happen? You just tell me. That request is going to be rejected. Why it is going to be rejected? Because that timestamp what we are providing, that is going to be expired now. After 5 minutes, that timestamp what we are passing in the signature, you can say. So based on this
Okay.
timestamp, the server will identify this is an invalid request. Within 5 minutes, this nonce value is going to tell going to tell the server, yes, this is a reply attack. Please reject this one.
Okay.
Then
Thank you.
after 5 minutes, timestamp will come into the picture. Before 5 minutes, nonce will come into the picture. If the user does any changes within the request body, then that signature is going to right restrict the request. And the hacker can never generate the signature. Why? Because for generating the signature, that client secret is required, which the hacker doesn't have. And that signature
Okay.
also we are not sending in the request. Right. So
Correct.
this signature,
Thank you.
whatever we are printing, we are not sending the signature in the request. So a hacker can only come to know what is the client ID, but he never know what is the right signature. So as he doesn't have any idea about the signature, he can never generate the right that HMAC signature. Clear? All the scenarios are going to be handled by this HMAC Authentic. So this is not related to your user authentication and authorization. This is related to authenticity and integrity. Whether the
Yes.
request is coming from a valid client or not. If someone in between modify the data, if someone sending the same request again and again, so that what it is going to check, but not authentication and authorization. So the good approach is go with JWT plus HMAC plus encryption and decryption. So now you can see whatever the data we are receiving or whatever the data we are sending. So that data we are sending in plain text. So instead of sending this information in plain text, we can also send this information in a encrypted format. So a client will send the data in an encrypted format. When the server receives the data, he will decrypt it. And so once the server returns the data, server will send the data in encrypted format. Client once receives, then client needs to decrypt the data. That encryption, decryption, plus HMAC authentication, plus JWT authentication, combination of these three things will give you the best security in your real-time applications. Clear?
Yeah,
Yes.
pleasure.
Anyone else having any more question, guys? Thank you, guys.
So, sir, tomorrow what will you start?
Tomorrow there is no session.
like next session on Monday, right? And then what's topic you will cover?
Sorry.
So next session will be on Monday, or like what the next you are going to start?
So we are already there, right? I think you are in, right? You are not attending. So already Angular session started now. So
Yes.
Monday to Friday, what I have already informed, Monday to Friday, our Angular sessions will be going on. And on weekends, right, I'm going to take the remaining part of our ASP.NET Core. So today we discussed this one. In the next weekend, I'm going to discuss encryption and decryption.
Oh, okay, sir.
And Monday to Friday, our Angular session will be go. So that at the end of the Angular, whatever the remaining topics of ASP.NET Core will be paid, that what also we are going to cover. So once the encryption decryption, after encryption decryption, I'm going to discuss also SSO authentication. SSO also very, very important. Clear? And after SSO, we are going to discuss filter concept. Okay.
Okay, sir.
Hello.
When I get this video, I want to,
Sorry?
this video.
Yeah, this video I will upload to my Telegram group right tomorrow only. Today it's not
Okay,
possible.
okay, fine. Thank you.
Hello.
Yeah.
On Monday, are you taking the microservices?
Yeah, Monday morning I'm going to take that microservices, right? GraphQL. In Monday morning,
Okay.
we are going to discuss GraphQL. Tuesday morning, we are going to discuss cost.
Sir,
Okay.
in microservices, we are going to cover this MTLS part, that service to service communication. Uh,
So, inter-service communication, right?
yes, sir. Because in current project it is being used, so I'm not sure like how they are using it.
Can you please elaborate what you are talking? MTLS.
Yes. So
What is it?
yeah, like when the services will be communicating that microservices, so they both will be validating like each other. So TLS certificate some.
Yeah, that is not related to right what I can say your development. That is related to your right how you are hosting your application, right? How the TLS handshake is happening. That is going to be managed by your infra team, server to
Mhm.
server communication, right? So from one server, right, to how you are right from this server, that request can come from that particular server, not from outside server, right? That is going to be different related. That is not related to your development. That is more related to your infra team. So in your
Okay.
company, do you have the infra team?
Yeah. It
They
is
can
there.
handle all these things, right? Because
Mhm.
that is
In our syllabus also I saw. That's why like I thought.
right. So that is fine, but I can only help you right regarding this theoretical part. Practical implementation, I cannot show you because for that purpose you need to buy the SSL TLS, right? And you should have multiple server. That practically it's not possible, but yes, that is possible. But for that purpose, you need to right, communicate with your infra team.
Okay.
Right? So what I can only help you regarding the microservices development part, not right that SSL. I'm not going to buy any SSL or a TLS, right? And I'm going to show you even for that purpose you need multiple server, and how from where I will bring all these servers. That is not possible.
So with respect to with the client, will you able to say like authorization code, client credential, different types of authorizations, those
Sorry?
things. Now we are only focusing on API side. Will be able to take with UI also so that we know end to end.
So that is the reason why Angular I'm taking that.
Okay.
So what I'm saying, so I have not discussed one important part that is identity. And once
Mm.
we have discussed the Angular main concept, right, then I will take one real-time example. Front end is going to be Angular and back end is going to be Web API. At that time,
Okay.
I'm going to discuss, right, how you can authenticate using your email ID and password, how you can authenticate using your mobile number, how you can authenticate using your oath like Facebook, Microsoft, Google, right? All these things I'm going to discuss. How you can integrate SMS provider, how you can integrate email services, how you can implement two-factor authentication, account lockout, right? All these things, how you can force the user to change the password, how you can force the user to change the password in every 6 months, right? What is the best way to implement forget password, change password, right? All these things we are going to discuss, right? So one user can log in from different devices, how we can manage those sessions, right, separately, how to provide right logout from all devices functionality, everything is going to be there. That identity complete database I'm going to explain.
Okay, sure. Thank you.
Right, so if you are going to generate right password reset link, then how you can ensure that reset link is going to be valid for 15 minutes, only one time the user can use that link. So everything I'm going to show you practically. It's very interesting, and that is the reason why I have not discussed that part till today. Why? That to understand, you need the user interface. Without user interface, how I can make you understand all this concept, right? You want to implement a Google authentication or Facebook authentication. If there is no UI, how you can do this thing? Okay, yeah. Thank you, guys. It's already 11.
Thank you, sir.